Good morning mga ka-geometries! This morning we are going to talk about the principles of transformations. In this discussion, we will be exploring about the types of principles of transformation, and that includes translations, reflections, rotations, and dilations. These four these four are the basic types of the principles of transformations, and we'll be discussing its definition and how it is applied and how it functions. Now, let's go! Okay, so what are transformations? So, come to think of it, transformation. So, there is something that is going to happen after an event happens because there is a transformation. It could be a result when something is applied. So, looking into our screen, what are transformations? Transformations are geometric transformation is an operation that changes the position, size, or orientation of a figure in the plane. So basically, it is something that changes from the original position of sides of a plane. Another, transformations are functions that map every point of a geometric figure to a new location, forming an image of the original figure. So it is also specific because it doesn't just change on its own, but it also determines what would be the position after it transformed from a to a different location, because it could be located in a plane and the points must be specific after the plane is being transformed. And so there are four types of transformations, namely the translation, reflection, rotation, and dilation. So here what we see in the figure is the shape or the plane. That is the example of the four types of transformation. First, there we have the translation, which is like the same from its original position. The rotation, which is basically rotates. Dilation, it seems like the shape gets smaller, and with a reflection, the image is being reflected from its original position. And now let us dig deeper about the principles of transformations. First, here we have the transformation of translation. So what is transformation of translation all about? So translation is a type of geometric transformation where we move or slide a figure from one place to another without rotating or changing its site. This movement occurs in a straight line, either horizontally or vertically, or diagonally. And in translation, every point of the figure shifts by the same distance and in the same directions along the parallel lines. So as you can see in the figure, as the pre-image is being is applied with translation, it now sends to um, the first quadrant of the coordinate plane. And basically, it is because of the transformation of translation, where the movement of um, the image is in straight line, either horizontally, vertically, or diagonally. That is why it doesn't send below from its original image, but instead it um, sends on the right side of the image, because the transformation happens in a straight line. Again, it could be horizontally, vertically, or diagonally. And as we can see in the figure, as the pre-image is now being translated to the other quadrants, its original coordinates is also been moved because it is located in a Cartesian plane. So there is coordinates involved. So example from the pre-image, the coordinates of A are -5 and 1, and when translation is applied, it has now the coordinate, like the translated image has now the coordinate of 2 and 4, and same applies with other points in the plane. And that's how translation works in a coordinate plane. Now let us move on to the transformation of reflection. Reflection, we know that it is common in our daily life. It could be in a mirror, it could be in something that reflects light. But a reflection in geometry, it is a geometric transformation where we flip a figure across a line called the line of reflection. So in this reflection, in this transformation of reflection, there is a line of reflection involved because it determines where would be the reflected image locates. Furthermore, this creates a mirror image that keeps the original size and shape of the figure but appears flipped or mirrored. So when we reflect an image geometrically, its sizes and shape is it's still the same from its original, but its coordinates, like the coordinate of its point, now altered because it is now located or tracked on the same on a different quadrant. So thus its coordinates becomes altered. And the reflected image, of course, it depends on the line of reflection. When the line of reflection is in the y-axis, then basically it would be under the original image. And for the third one, we have the transformation of rotation. So what is transformation of rotation all about? Of course, we already have an idea what would be because from the word rotate. So the image become rotated. It could, and this there would be an angle um, involved because when we rotate something, of course, there is an angle involved. It could be into 90, 180, or more. So here, rotation is a geometric transformation where we turn a figure around a fixed point called the center of rotation. So if there is a line of reflection for reflection, so there is also called center of rotation when it comes to the transformation of rotation. Following a rotation, the size and shape of the figure remains the same. Furthermore, the transformation that rotates each point and the shape at a certain number of degrees around that point is called rotation, as we have mentioned earlier. The shape that rotates counterclockwise when the number of degrees is positive and rotates clockwise when the number of degrees is negative. And finally, for the last example of transformation, the transformation of dilation. So what is dilation in geometry? Dilation is a geometric transformation that changes the size of a figure while preserving its shape. The resulting figure can either be enlarged or reduced. And in dilation, we move each point away from or towards a fixed center called the center of dilation. And a scale which determines how much larger or smaller the figure gets. So the original image could be enlarged or reduced dependently on the scale factor. When the scale factor is greater than 1, then it, it would be enlarged. And when the scale factor is lesser than 1, then the image would be reduced. But it still preserves its original shape. And those are the 4 examples of the principles of transformation. And to summarize it all, I have prepared a table for you guys for you to easily remember the function and the result of each of the example of transformation. So we have for the rotation, the function, it rotates or turns the pre-image around an axis. Its result, no change in size or shape. And for the reflection, the function, it is to flip the pre-image and produces the mirror image. And as a result, no change in size or shape or orientation because it is just being reflected. And for the translation, its function is to slide or move the pre-image. And as a result, no change in size or shape, but changes only the direction of the shape. And for the dilation, its function is to stretch or shrinks the pre-image. And with its result, it expands or contracts the shape, but it still keep the shape. It doesn't change the shape. It only reduce or enlarge dependently on depends on the scale factor. And that is all about the principles of transformations. Hope you guys learn from all that we have discussed. Thank you and God bless.